Hello everyone, welcome back to Intellect Expanse. What we have on the bench today is a true icon of the mid-80s, the Toshiba T1000. Released around 1987, this was one of the first truly portable PCs. But looking at the exterior, it's definitely wearing all 40 years of its history. Taking a look at the screen, we have a 640 by 200 pixels monochrome panel. Since these early LCDs don't feature an internal backlight, visibility depends entirely on your external light source. Surprisingly, the panel is in great shape, no signs of vinegar syndrome or physical degradation. On this side, we have the contrast knob for the screen, the floppy disk drive letter selector, and an external keypad connector. On the opposite side, we find the internal 720K floppy drive. Here we have the power jack, the main power switch, a CGA port for an external monitor, an external floppy connector, and standard parallel and serial ports. It even features a built-in modem, which was a high-end addition for a portable at the time. Let's get inside and see what we're working with. To open the unit, we first need to remove these 6 screws on the bottom. These feel like they haven't been moved since the 80s. They're quite tight, so I have to be careful not to strip the heads. I have to point out the integrated carrying handle. It's such an interesting feature for this era of portables. Unlike modern laptops that require a dedicated bag, the T1000 was designed to be picked up and carried just as it is. It really reinforces the idea that this was meant to be a go-anywhere computer. You can also see the speaker grill here on the bottom of the chassis. It's an unusual spot for audio, especially by today's standards. Most modern laptops try to fire the sound upward or toward the user. You aren't going to be listening to high-fidelity music on this anyway. It's mostly meant for system beeps and basic software feedback. Alright, all the bottom screws are out. And apparently there are no other hidden screws that I can see. Now we come to the most delicate part of the disassembly. Even with the screws removed, the case halves are still held together by 2 internal plastic clips. These are notorious for breaking because they become very brittle with age. The first clip is located over here on this side. If you look closely at the seam, you can see where a previous owner likely tried to pry it open with a screwdriver, leaving some visible damage in the plastic. Since this old plastic is so unforgiving, we have to be extremely patient while working these halves apart to avoid snapping the tabs. I prefer to take my time and work carefully using only plastic tools. This ensures I don't mar the finish or put unnecessary stress on the internal tabs. Good lighting is also very important, so you can see where the tabs are located. Done! The clip was actually positioned further to the right of the damage. The second clip is at the rear, situated right above the external floppy connector. It requires the same level of care to ensure we don't add any fresh cracks to the chassis. And done! This half is ready to be lifted. Once the top cover is free, we need to carefully disconnect the delicate ribbon cable that connects the LCD to the main board. Let's clear some space and remove the modem first. It's held in by 2 screws and a single flat cable. The modem actually appears to be in excellent condition. I'm checking the areas around the components, and I don't see any visible capacitor leakage or corrosion. I'm not sure if I'll be able to test it fully today. Maybe we can pull up a terminal and try some basic AT commands just to see if it responds. Next up, let's disconnect the battery. On a machine this old, the original NICAD packs are almost certainly dead. I'll pull it out and test the voltage later, but I'm not holding my breath. In fact, I'll dedicate a separate video to testing and rebuilding the battery pack, so keep an eye out for that. The electrolytic capacitors actually don't look too bad at first glance. No bulging or obvious leakage. I will perform a much more thorough inspection once the board is fully out of the case. I'm removing the floppy drive now to get full access to the motherboard. There are 2 screws here on the bracket, and another one tucked away over here. With the screws out, we can disconnect the 26-pin data cable and remove the floppy drive. Overall, the board looks remarkably clean. No signs of the typical green corrosion caused by leaking batteries or capacitors. But wait, there's something right here in this section. Let's get the camera in for a closer look. See that? It looks like old flux residue from the factory, but it's gotten really crusty. A little bit of isopropyl alcohol and a cotton swab should clean that right up. Yep, definitely just old flux. It's dissolving nicely. Alright, much better. Looking closer at the traces, there is a tiny bit of capacitor leakage right here. Thankfully, it hasn't started eating through the copper yet. Since we've got the swabs out, let's give the ROM chip a quick clean too. Just getting rid of years of dust and grime. Alright, nice and beautiful. These small capacitors look fine visually, but given their age, they are replace on site for me. I'm going to swap them out for fresh ones to ensure there is no leakage in the near future. These bigger ones will have to go as well. I'm not taking any chances. Overall, this is a very healthy looking board. Let's see if it actually still works. I'm going to use my bench power supply instead of the original adapter. This allows me to precisely monitor the current draw and catch any potential issues before they cause damage. I'm setting the supply to 5 volts with a 700 milliamps current limit just to be safe. Okay, power is on. No magic smoke, no smell of burning electronics. That's always a good sign. Let's turn the laptop on. It tries to start. The LCD flickers, but it won't stay up. I'll try cycling the main power switch on the bench supply to see if a fresh start changes the behavior. No, same behavior. However, the power supply isn't hitting the current limit, which is encouraging. It means we aren't dealing with a hard short on the rail. Let's do another pass over the board to see if there are any other details we might have overlooked. If we look closer, you can see some evidence of leakage right here. It's subtle, but that slight shine around the base of the component is a clear sign that the internal electrolyte has started to seep out onto the board. Before proceeding with further diagnostic testing, I'm going to go ahead and perform a full recap of the board. To do that, I'm going to remove the board completely from the chassis. This will give me the clearance needed to desolder the capacitors and thoroughly inspect the underside, which is densely populated with components. Turning the board over, you can see just how much is going on underneath. It's a complete city of components down here. I'm looking for any dull solder joints or traces that might have been damaged by electrolyte migration from the top side. The bottom of the chassis is in great shape. with no signs of corrosion or pitting on the metal shield. While the top side holds the larger through-hole components and connectors, the bottom is a dense city of surface mount components. All these components add a layer of complexity to the repair. I'm paying close attention to the areas directly beneath the top side electrolytic capacitors. Even if the top side looks okay, electrolyte can sometimes seep through the via holes and begin eating away at these tiny surface mount pads and traces underneath. I'm looking for any signs of crustiness, dull solder joints, or that telltale greenish-blue oxidation. Despite the age of these components, the underside and top side of the board appears remarkably well preserved, with the solder mask still maintaining its original luster. However, in vintage restoration, visual inspections can be deceiving, and I'm not taking any chances with potential invisible contaminants. Electrolytic fluid can be conductive long before it becomes visible to the naked eye. So before I even consider bringing a hot soldering iron near these pads, we're going to perform some localized cleaning. I'll be using 99% IPA to clean any leaked electrolyte, ensuring that when I do start desoldering, I'm working on a perfectly clean surface and not baking old corrosive salts into the solder joints. Okay, capacitors have all been replaced and the board has been thoroughly cleaned and dried. Let's see if it boots now. Okay, power supply is connected to the board. Speaker also connected. 5 volts, 700 milliamp limit. And stayed on this time. And did you hear that? It beeped. In the world of vintage computers, beeps are the most beautiful sound you can hear. Now that we've confirmed the board is showing signs of life, let's get the LCD reconnected and find out if we can actually get an image on the screen. Power on. Okay, the screen is just a solid block of dark pixels. The contrast is set way too high. Let me adjust the knob on the side. Yeah, much better. Look at that! Memory test passed. And it booted perfectly into the built-in DOS version 2.11. What is the system date on this thing? 1980? Man, this really is a time capsule. Hope you enjoyed the video. If you did, give it a like and consider subscribing to the channel. Thanks for watching and see you next time.